working on understanding that, really? No. Okay. We're working on understanding that we can take operations and use them to create new quantities without necessarily having to do that, right? It's not just an action to do. So can someone tell me, what's the first thing that they did? Any? Ask.
We had to find the height.
Okay, and how'd you find the height?
We used the Pythagorean theorem.
With what?
5 squared plus x squared equals 9 squared.
Except it can't be 9 squared because you see how
13
there you go, wonderful. All right, so if you wrote 5 squared plus, no, right? It's 5 squared plus what squared equals 13 squared. So if you wrote 13 squared minus 5 squared, here's the side of the trapezoid. And here's the height of the trapezoid. And then, once I square them and subtract and take the square root, this is...
Isn't 5 just part of the base?
Thank you. So what should we call it? And again, there's no one right answer. Maybe like the bottom of the triangle, right? Base of triangle. Right? Because in order to see this, what you have to do is think about this, come on in, this triangle right here. All right, wonderful. Okay. What next? Somebody else, add to that.
Can I ask a question? On our paper, do you want us to write side of trapezoid and base of triangle as well when we're labeling?
Yes, please. Again, it's only something we'll do as an activity because it takes too long on a quiz or test, but be thinking about that, right? And so what is this whole thing now? This whole thing is the height of the trapezoid. Wonderful. I have a hand. So what did you do next? Somebody. Nobody? Was it Haley? I know you, John. No, tell me.
Wait, it's Haley now.
Okay, go ahead. You had your hand raised. What did you do next?
Oh, well, we took the area of the trapezoid first, and then we subtracted the areas of the triangle. I mean the area of the circle.
Okay. And so you don't have to work up. You can also work top down, right? You can say, oh, I'm going to start with the area of the trapezoid minus the area of the circle, and that's a good problem-solving strategy for how to break down. So what else do I need in order to get the area of the trapezoid? All right, I'm going to randomly point. Yes?
The two bases,
Mm-hmm. And so what are the two bases?
8 and 18.
8 and 18, wonderful. So then you do 8 plus 18. This is top base. This is, I should be writing the quantities more carefully. Length of top base, length of bottom base. All right, and then what did you do with those after you added them?
Multiply it.
By half, right? And then multiply that by this. And so what is this?
The area of the triangle.
Wonderful, area of trapezoid. All right, we're done with the trapezoid. Now you come over here. Miguel.
Subtract the area of the circle.
Yep, we have that. What do we do?
R squared.
Pi r squared, but we don't have r, so what can I write down in place of r?
The height of the trapezoid.
Wonderful.
Divided by
And so it becomes 6, right? Am I doing it? That's 12. Wonderful. And so what should I put in there? If you wrote 6, it is correct, but not if I'm asking for open expressions. June. Oh no, Helen, good.
12 divided by 2.
Except we don't have the 12. Can you adjust that a little more? All right, with the 12
Square root of 13 squared minus 5 squared.
13 squared minus 5 squared all over 2. Right? So then here's the height of the trap, or you can even rename it, right? It's not only the height of the trapezoid, it's also what? diameter of the circle, and therefore this, once you also add the divide by 2, is the radius of the circle, which makes this the area of the circle, which makes all of this, what?
Yes.
The area of the sheet.
It is the answer, and the answer is the area of, you could either say shaded area, or you could say between the trapezoid and the circle. As long as you have all the numbers. Yeah. Oh, I don't care how pretty it is, really. Okay, if everyone can kind of pass them up forward here. And we're going to continue with reviewing these 7, and I realized actually 8 shifts. How much time? Kind of 20. All right, we have 25 minutes to go over these shifts, because starting tomorrow we are in chapter 4, and we're talking about the 2 questions that calculus can answer.
So do we not have a test tomorrow?
No, we do not. However, we are. I should do announcements. Okay. Yes, it got pushed to next week. And then since I didn't put up new homework, I forgot to put that up. So, I think I already fixed the syllabus. I'll check again, but I'll also put out an announcement. So the test is Wednesday, whatever week from tomorrow is. What's tomorrow, the 7th? Yes, 14th. 9th. Okay. Tomorrow we are going to have a function and function notation quiz, which is why we're going to go over those today. And my office hours tomorrow are canceled, almost sermons, because instead I'm doing a long review session next Tuesday. But if you can still come to, you can still make appointments with me. And also, I put a different one on Thursday to get replaced. And I cannot, oh, I'll just go backwards, hold on. There. Thursday, 9/8, 1:30 to 4. Okay? So instead of tomorrow's office hours, I'm putting office hours the day after tomorrow. And as soon as I hear from the whole calc group when our review sessions are, I will post them for you. There's going to be one Tuesday during the day and one Tuesday at night. I'll be at the one Tuesday at night.
You told us that you're doing online homework?
Yes, thank you for reminding me. I'm so sorry. So remember how I wrote a deadline for myself? It was a really hard weekend and I had problems. If I miss my deadline, I'm not going to hold you responsible, okay? That's going to be homework due tomorrow. And there's only going to be online homework due tomorrow. Okay. Yeah, so I'll always do that for myself just because I know that I am also disorganized. And I'll put a deadline so that if you see the deadline's gone by, you don't have to worry. Yes, I had a question up here.
Can we schedule a meeting with you?
Yeah, absolutely. Can you come up afterward, right after class, or email me? Okay? Yes. All right, so we talked about, I still have that backwards. We did all of this. Let me move forward. We did that, we answered that. All right, from thinking about integers to thinking about all real numbers. All right, and so this one is a hard one because it's very hard for me to write questions and activities that directly target it. It's more that, let me go back for a second. It's more that you need to be able to think this way in order to do all the other things. So for example, most people know the answer to how many numbers are there. They say infinite, but then it's not incorporated in their meanings, right? It's one thing to be able to answer a question only when I ask a question. It's one thing to be able to answer only when I ask the question in a specific way, but it needs to be so integrated into all your mathematical meanings that no matter how I ask the question, that is one of the tools that you use always. It's always one of the tools you pick up. All right, and so we also need to be thinking about really, really tiny little bits of change. That's why we're focusing on this, because that's what calculus is about. And so we need to think about a variable's value changing smoothly through all those real numbers. And again, I don't have any specific tasks about this. It's a meaning, and it's going to come up in a couple of the shifts that we're talking about. So let's talk about variables. Variables stand for unknowns. Everyone says, oh, a variable varies, and then when you ask a more specific question, they kind of go back to whatever you kind of did in elementary school, because honestly, if you're not challenged to go beyond that, then it usually doesn't happen. We need to switch or shift to thinking that variables vary. So we did this exact activity. Let's see if you can put it into words. First, Bob says x is a variable whose value varies, but then when he solves x plus 3 equals 5, he says x can only be 2. How would you clarify this contradiction for Bob? Talking in groups, go.
X has to be
Ramiro, are you here, Ramiro?
What are you saying? It just holds place. Unspecified or unspecified.
Corey Cooper, am I missing you, Corey Cooper?
It's killed like 2 guys. How good is that? Yeah, I'm still working on it.
Yeah.
I would think the only difference.
Alright, so let's come back together. And really quickly, tell me if you're here and I somehow missed your face. Ramiro, Corey Cooper, Rosalind, Spencer Hardy, Corey Hooper, Andrew. Okay. Alright. So who can volunteer to resolve this conundrum? Oh, Andrew. Alright, who can volunteer to resolve this? How can you, going back and forth? Yes.
Okay, so x is 2 for this equation, but it's not for this equation because x varies.
Does it vary within this equation?
No.
Alright, we have x does not vary in this equation, but it still varies because of all equations. Second person, come on. Close. Chanel, yes.
You said that like x varies, but to make the equation true,
So x varies, does it x vary in this equation?
yeah, but it wouldn't make the equation
Alright, so x varies even in this equation, but that is the only number that will make the equation true. Do I have any third answers? No. Alright, so remember if I think I have it already pulled up. We had that animation. Whoa, if I can find it. Here it is. We had an animation. And I said, think about this. And then I played it. Right? So it is indeed, yes. It is indeed that within every single situation, you want to think if it's a variable, right? Do you remember the word for a letter that represents something that doesn't change that we went over?
Constant.
Parameter. If it's a constant, that was not a very clear question. Kind of both right. Pi is a letter that is a constant because it never ever changes, right? So it's 3. But what about if it's a constant in one situation but it changes across situations? Then it's a parameter. So make sure that you're not only thinking about this as a parameter, but about it instead as a variable. Every time we call something a variable, it's varying smoothly throughout all the real numbers, or at least through its domain. And so what makes 2 special? 2 is not like what x is, right? So what's the vocabulary we use instead so we can stop thinking x is 2? What's 2? Wonderful. So 2 is the solution. It's the value of x that will make the equation true. Go away. But it is not the only thing that x can be. Wonderful. All right, so let's go on to our shift 5. Thinking of shifts as going from graphs, as thinking of graphs, I'm so tired right now, as going from, first you think of it as a curve, right? It's almost a piece of wire. People think of it as like lifting it up. If you add 2 to a function, you just kind of take that entire curve, like a piece of wire, and you like slide it up or slide it down. Going from that to thinking about it as points, and going from that to thinking about it as infinite number of points. I'm sorry, to go, let me try that again. Going from it to thinking about it as a curve or a piece of wire, to thinking about it as an infinite number of points, right? Not one thing, but representing an infinite number of points. And then thinking about each of those points as representing 2 different quantities at the same time. Okay, so let's talk about this one. The quiz question that everyone was like, when I went over in class. Instead of getting mad about it, how can you guys take, I'm going to take 30 seconds, then I'm going to ask for volunteers. If you got it wrong, or if you can think about how other people got it wrong, instead of just, oh, I memorized it wrong, what do you think people were thinking in order to not get these right? And again, do you need to go over the answers? What are the answers? Points going across are, how many points? And measurements. This one, I mean, it's technically like 2 times infinity, which is, of course, still infinity, right? So each time the measurement has to be twice as many as the points. All right, take a second and talk. What were people missing in their way of thinking?
Yeah. I was looking at I thought about like how did I think
She said she would know.
I'm going to ask each group to give me a comment. So each group, you've got to come up with at least one comment on how you think people were thinking, so that then we can think about how to make that shift in the future. A comment for me? All right. Is that a comment? Something to say? Oh, okay, so let's go ahead and begin, because I think everyone discussed. Jess, do you want to give your first comment? What do you think it was that people were thinking that allowed them to not answer 5 infinite, infinite, 10 infinite?
So I know for number 2, I like in math class you kind of like learn that a point is like an intersection on a graph or a curve or line or whatever. So when I looked at 2, I didn't see like any like dots, like points type things. So in my head, I was just like they're all measurements and not points when they're both.
Wonderful. Okay, I think that's a great way of thinking about it. Yes, Kate. I didn't do my flashcards this week. Yes.
The last one.
The last one, yes.
Like, our group talked about a little bit how it was kind of like a combination of both of them, and that kind of threw us off. So it was like one thing that went through our minds was that like, which do we go with? What do we think it is? That kind of
Absolutely. Everyone has great comments. I want to piggyback off of that. Does this one have 5 more points than that one? It's rather that they're highlighted, right? And again, my whole point of in-class activities and quizzes is to give you those little things like, oh, this is the little thing that I'm thinking in a certain way, so that when you get to the test, you can do it. All right, I had so many hands. This was great conversations. Keep going, Helen.
I know we were talking about it, and we were, I think for the third one, because
there were only 5 distinct points, we thought of that as like 10 measurements, only because of those were the ones that were distinct.
Wonderful. And again, so we want to, it is easy, like, I feel like if I had given you guys just, let's see, how would I put it? I'm going to ask for more comments because my brain is all shot. I'd hand here and then I'm going to come over here. Yes?
I've just never heard the word measurements be referred to.
But we did do it in class and in the book, so, but that's all right. Moving forward, measurements of quantities, right? There's some quantity on the x-axis. If I don't label it as like pounds of hamburger or whatever, then it's just, we're just going to call it the quantity. And how many measurements is there? We've been drawing them, right? Here is something represent how large the y value is. Here's something represent how large the x value is. Other comments? Yes?
And like some of us actually thought of the answer infinite, but it's such an unused answer. We had doubts about choosing it,
Okay.
so we had to go with the more common of 0 or just 5.
That's fair. All right. So that is a good point. Remember that it can't just be like what's typical. For example, how do I explain this? So do you remember how when I gave you the online homework, I asked you like really vague questions that I would never ask you in a homework or test? Because there was like no one right answer to a couple of those online homework questions, right? I said things. Like I would never say that on a test because then I'm not sure what you know about things, but we're trying to see what you draw out. So do make sure that you're not thinking about like what types of things are the right answers based on previous knowledge and rather just go with what has to be the right amount. Thank you. Yes?
I think for the first one, it's an automatic assumption that since there's 5 dots on the graph, then that would mean points, but people didn't like understand that x is a separate point and y is a separate point.
Wonderful. It is so hard to think about. Sorry, everyone. I'm just doing my parking because I hate parking today. Okay, so we looked at these 5 points, and we do. So what we talk about, you don't have to know this word, but in research we talk about points as multiplicative objects because you have to think of them as multiple things. And it's not intuitive, right? It's not common sense. I see 5 things. I see 5 things. I'm really supposed to think about 10 measurements. So that's why we do have to be very careful and very intentional. Thank you, guys. All right, any other comments? Charles?
I actually have a question. You're saying it's infinite, but why isn't, in a sense, infinite? Because the line stops at 0. So I had a curious question. If the answer would be x is infinite and y is greater than 0, would that normal?
Oh, okay. So I think what you're doing is you're doing a confusion between domain and number of. It is absolutely true that y doesn't cover all the numbers in all the real numbers, but even from here to here, there are infinite points, right?
But that's what I'm trying to understand. Is there technically, because you are still limited the y-axis in a sense, so you're still not getting all infinite numbers.
You are, because not only is it, so if I draw my number line, and this is a great question. You guys are doing really well at coming up with these things to discuss. If I draw a number line and ask you, and it's going on forever, how many numbers are there in this whole number line? There's infinite, but there's also infinite just between here and here. There's also infinite just between here and here, right? It's a complicated idea to get your head across in order to apply it in a question that you haven't directly been asked before. Thank you. Any other comments? Yes?
I overthought this question because like I thought it was a trick question, so I kind of like overthought it like more than the measurements. I thought it was gonna be infinity for every single one because like even on the first one, I thought you could still find like the measurements of other points even though they're not highlighted.
Okay. So for that, make sure, remember, I can't remember which section it was. I think 3.9, but when we talk about a displayed graph, and then you really want to only look at the things physically printed on the page. Thank you. So everyone keep that in mind as another thing that you might want to avoid. And any last comments before we move on? All right. So let's go now to the 6th of our 8 shifts. You don't have to memorize the shifts, right? I'm never going to ask you to write down all 8 shifts. That's not the point. So thinking from a function is a formula, right? If I write down f of x equals 3x plus 5, it's a formula. But if I write down f of x, people think, oh, this person hasn't finished writing yet. But even then, I'm still describing an output of a function. And also that it's predictable. The easiest thing I like to think about is like an Excel spreadsheet. If I have an Excel spreadsheet of like the temperature for every minute of all of 2015 in, let's say, this room, there's no predictability to it in terms of like, oh, I'm going to find a pattern and then it's going to be easy and I'm just going to plug it into a formula, right? Like it's going to be almost impossible to find some formula that I can plug it in. It doesn't have to be predictable. However, I should be able to predict only that there's going to be one output for every input. If I pick a minute, is there truly only going to be one temperature measured by whatever thermometer is in here at that time? Yes, right? Because if you look at like your home thermostat, it never has two numbers going back and forth. It's only got one. So that is what defines a function. Let's take a couple of minutes. And at ASU, which are functions of which? Can you first tell me how many different things, how many different tests for like, oh, is this a function? Is this a function? How many tests do you think you're going to have to do? Think about it for a second, and I'm going to ask, talk, and I'm going to ask you to yell it out loud. Like, how many different things are you going to have to test? Are they functions or not? Alright, pull you back for just a second. Even before you check whether they're functions, how many potential functions can be described with these three things? 1, 2, 3, yell. Sure. Alright, we've only talked about functions with inputs and outputs, right? I'm not going to make you do anything. Do we do them later? No, I don't think so. We're not going to do anything with like multivariable functions. So, if there's an input and an output, how many different ways can you organize these into inputs and outputs? 6. Wonderful, right? You have to take each pair and you have to say, is blah a function of blah? Answer that, and then is that one a function of the first one, right? Alright, so take a couple of minutes and decide for as many of those 6 as you can get through, are they functions or not? Go. Oh, right. So then you're saying people at age. But I'm just wanting you to go back and forth. Yeah. ID number 8, age of ID number. ID number 5. Any questions you want me to come around before we go over there? Also, it's time and age and time. ID number, age, ID number, and then ID number, time. Because every function needs that variable value. Any question you might be correct? Okay, so let's go over it. If I say blank is a function of blank, which one of those blanks is dependent? Or the y? The first one, right? Y is a function of x. You can also say x is a function of y, but not what? X is your dependent. So is student ID number a function of age? As in is student, and the easiest way is to replace is a function of with respect to all of that with uniquely determined by. Is student ID number uniquely determined by age? No. I give you an age, will you immediately only have one student ID number to me? No. Alright, so student ID number is not a function of age. Is age a function of student ID number? Yeah, for every student ID number you give me, there's only going to be one age at this moment in time. Alright, is age a function of what time you woke up on August 29th? No, I give you a time you woke up, you can hand me multiple ages of different people that woke up. Is time woken up a function of age? No, if I give you an age, you can still give me lots of times that people that age woke up because there are so many people that age, right? Is student ID number a function of time woken up?
No.
No. Is student time woken up a function of student ID?
No.
Yeah.
Yes, because time woken up is uniquely determined by the student ID number, right? I only have 1 more minute left, so please hold on. We have been working on this. Our shift number 7. Function notation is in order to calculate, or can you represent it? Remember all those problems with the 2 running people? Where you couldn't calculate it because I didn't give you a formula, but you could still look at like how to represent it. Like you could write down f of 0.15, and that would be how far Usain Bolt had run after 0.15 hours, even if you couldn't give you the number. Okay. So what I'm going to do for homework, it's going to be on shift 6 and 7, so all about function, and I'm going to put up homework. I can't promise it'll be up before noon, so let me give like latest 1 p.m. The online homework will be up, and the questions will do a good job of preparing you for tomorrow's quiz. Okay? Is on what's a function and using function notation to represent stuff, even if you can't calculate. Have a wonderful day. Come up for questions, appointments,